Okay, so now we're going to look at order of operations evaluating expressions. So we're going to take what we knew about order of operations and what we've done with evaluating expressions with variables in them, and we're going to combine them. So for example, they have evaluate 3a minus 2 to the third power divided by b for a equals 7 and b equals 4. So in this one, we have an expression with two variables. We do not have an equal sign, so it is not an equation. You are not solving for a variable. They also gave you the value of two of the variables. The first thing you are going to want to do is you need to substitute. So the very first thing before you start doing any solving is you're going to substitute 7 for A and 4 for B. And so if you notice, what they did is they took the original equation, they sectioned off the A and the B, and their second time they write the expression, they substituted the 7 in for the A and the 4 in for the B. Once you do that, you can evaluate as normal. You don't have to do anything else, because your first step when you are evaluating formulas is to substitute your variables for the value known. After you do that, you simplify. You do the exact same order of operations. In this one, there are no parentheses, so you would start with exponents. And you have 2 to the third power is 8. So you have 3 times 7 minus 8 divided by 4. And here's an example of working multiplication and division from left to right. You would not do 8 divided by 4 first. You do 3 times 7 minus, and here they did them simultaneously, so they did the multiplication and the division at the same time. If you're remembering and you're noticing that you're doing that, you can do that. And then you have 21 minus 2 equals 19. So the first step for using order of operations when evaluating expressions is to substitute the variables. Okay, so let's look at this one. We're going to evaluate each expression for A equals 5, B equals 12, and C equals 2. So let's look at this first one together. We have A plus B plus 2C. What is the first step that we should do when we're evaluating an expression? Yes? We should substitute the variable. So I would start with this. And if this is on your worksheet, like if this is in your math book, next year you're going to have a math book, a hardcover math book it's going to sit on your desk, and you're going to have to do all your work in a journal. You always, always, always rewrite your original equation. Never leave that out. So in your book, you would have I don't want that, want that one down. A plus B plus 2C equals, and then I'm going to start putting them in. So I would have A equals 5 plus B, which equals 12, plus 2, parentheses, C, that equals 2. Okay? So the first thing I'm going to do is substitute my values for my variables. Then I can start solving using order of operations. So what would I be doing first in this expression? What do I do first in this expression? If I did my substituting, I substitute my variables in. What do I do first? Yes? Huh? You don't know. What do I do first? I do the parentheses. In this case, the parentheses is, what operation am I doing here? Multiplication. So I have 5 plus 12 plus what? 2 times 2, 4. Now what do I do next? What's next to simplify? What am I adding? 5 plus 12, which is 17 plus 4. 17 plus 4 is 21. There's my answer. Do this one in your notebook or on your whiteboard, and then let's correct it together. Okay, so when you did the substitution, what did your substitution look like? What did you write when you substituted your values in for your variables? Morgan? That's okay. Got to back up a step. The first step you do is you only substitute. You don't do any operations. Your first step, you only do your substitutions.
Wait, can I fix that?
Parentheses 12, or you'd say 2 times 12. 3 times 5. Okay? That must be your second step all the time. Rewriting this is your first step. Substituting is always your second. Always, always, always. Don't try to do the operation in your head and then write the third step down. You want to be able to visually see every move you make. All right, so check your second expression and go ahead and do the third and then come back and check. All right, I want you to start with each of these expressions. So you're going to solve each of these for s equals 11 and v equals 8. Remember, your first step must be substituting your numbers in for your variables. That is the very first step you should do, and then continue to use the order of operations. Go ahead and do all three, and then come back and check. All right, so let's check quick. On the first one, we substituted 11 for s, and the 2 is attached to the v because there is nothing in between that, so it would be 8 squared. So 11 times 64, 11 times 64 is 704. In the second problem, you will see that the s and v are inside the parentheses with the exponent on the outside, which means you are going to multiply 11 times 8 first. You get 88 from that, and you would square 88, get 7,744. In the next one, you will see that it's 2 times s. The exponent attaches to what's in front of it, so it's 2 times 11. So you have 22 squared times 8, 484 times 8, so you get 3,872. All right, so we're going to talk overall about the order of operations. And what role does the order of operations play in writing and or simplifying algebraic expressions? First of all, order of operations is used to label algebraic sentences. Is it used to sequence the mathematical process? Is it used to divide fractions? Is it all of above or none of above? Check, choose an answer, and I will see if you're correct in 5 seconds. Your answer should have been B. The order of operations is used to sequence the mathematical process. It is the sequence that you use to solve math expressions or equations. Exponents. Another thing to keep in mind is an exponent tells how many times a number the base is used at a factor. A power has 2 parts, the base and the exponent. So your base, the exponent tells you how many times you are going to multiply that base by each other. You do not take the base times the exponent. So the exponent 3 with an exponent of 5 is read as 3 to the 5th power. And it means 3 times 3 times 3 times 3 times 3, or it can be simplified as 243. And that is it for order of operations. Make sure that when you are doing problems, when you have to simplify or evaluate, that you are using this in every problem that you do.